I want to talk a little bit about the ear today. We're going to talk about the parts of the ear, how pitch perception occurs, or one of the theories of it, and what do the nerves actually tell the brain. So, the first bit we need to talk about is the parts of the ear. And the ear can be broken down into three different parts. So, we have the inner ear, which is down here, that's the cochlea, and the middle ear, which has the eardrum, hammer, anvil, and stirrup. The hammer, anvil, and stirrup are bones. And the outer ear, which is the pinea and the ear canal. So the pinea and the ear canal are where sound initially comes in, and it allows us to funnel sound in. The pinea is used as one of the ways that we determine in which way pitch is coming from, for example. And the other way is through the difference in time it takes for the sound to get from one ear to the other. The pinea is about 6 centimeters. So if you think about the speed of sound, that means that it helps in detection of higher frequency sounds. And it also funnels the sound to the middle ear. And the middle ear is where a lot of the mechanical motion actually happens. So if we think about the middle ear, we want to think about mechanical motion. So I have an eardrum, which is sort of a vibrating membrane. And on either side of it, I have three of these little bones. And these three little bones act to sort of measure that motion. So I have sort of a lever, and I have the fulcrum of that lever, which can change, and our body does that automatically. And I also have the bones that sort of, in some sense, are like the beating on the drum, right? So the hammer and the anvil are named that because that's what they look like. And this mechanical motion is then taken to the inner ear, and the inner ear, from the vibrations in the eardrum and the interaction between the vibrations and the bones, is where I take this mechanical motion and turn it into nerve pulses, which is the purpose of the cochlea. So the ear's a pretty amazing instrument, and it allows us to perceive sound and direction. It also helps us with balance, and it allows us to hear very small changes in frequency. So the next question can be, how does my ear measure frequency, and how does it measure pitch? So when I think about the membrane involved in the vibration, the area of vibration is amplified depending on the pitch or the frequency of the sound that's involved. So let's remember that pitch is related to frequency. And the area that flexes in this membrane is a function of pitch. And this area of motion allows me to determine pitch perception. And that area is turned into, that vibration is then turned into nerve pulses. So what do the nerve pulses look like, and how do they sort of, in a summary way, determine my ability to perceive sound? So if I look at a histogram or a schematic of the nerve pulses that are being produced, where I'm taking that mechanical motion and turning it into electrical pulses that go down my nerves, there are sort of four pieces that are important. So one is the pulse regularity, which does seem to vary a bit in a way that seems irregular at first, but eventually through looking at it, we can see that it's related to the pulse period or multiples of the period. I also can think about loudness, and loudness is related to the average rate of the pulses. So the more frequently the pulses come, the louder it seems to appear. And those pulses only happen during the crest of the wave and not during the trough. The last thing is that these histograms, or these ideas of the pulse wave shape, if I have a pure sinusoidal tone, I end up with pretty peaked spikes, but the wave shape of the noise that's being made, the sound that's being perceived, is embedded in the details of the wave shape of the pulses, the electrical pulses that are being sent to my brain. So that's sort of an overview of the ear, and we don't have any questions on it, but it is important to understand these big picture topics. Thanks, guys.